Section 2, Electrical System. 1-4, General. In understanding the electrical system, it may help with the comparative it to the water system as one of the illustrated on the left of the figure 110 of the path of the water system, the pipe compared to the wires electrical system illustrated on the right of the figure 110, which forms the path called the circuit. In the water system, the pump supplies energy from the turbine and absorbs it, and similarly the electrical system, then the generator supplies the energy and the motor absorbs it. The water system, the pressure of the pump supplies varies, but the size of the pipe must allow the various pressures and the different sizes of the pipes and other than different resistance, so the quantity of the water flow in the pipe is affected with the characteristics of the water system as are paralleled by the like of the factors electrical system, whatever they call it, the volts, ohms, and amperes. These are often basic principles which are governed by the flow of electricity and related to the magnetic effects as discussed in this section. 115, the voltage. Voltage is the pressure of the current, is the pressure of forces current through the circuit. The pressure is supplied by an electrical generator. Battery is often called the potential difference in electrical motive force, EMF. When a circuit available for the voltage causes the current to flow, when the circuit is closed or broken, the current will not flow. In practice, the volt is defined as the potential difference or pressure which causes 1 ampere to flow from resistance to of one of the 1 ohm to the voltage of the pressure that forces the current through a circuit. 116. Resistance is the property of the material and the conductor which opposes the flow of the current of the voltage applied, which converts the electrical energy into heat. An ohm is one of the unit you measure to the resistance. The very small resistance are measured in millionths of an ohm, called microohms. Large resistance are measured in the millions of ohms and called megaohms. Materials that offer very large resistance are called insulators, conductors carrying electrical current easily, while the insulator often offer more resistance to the flow of the current. Although there are no perfect insulators, the conductor organic vitreous, figure 110, similarity between water and electrical system substance is such as rubber, oil, ceramics, and glass, usually made of the good insulators. The metal used Metal usually makes a good conductors. The resistance of an insulator is expressed in megaohms and measured by an instrument called megger. Alright, this figure shows the hydraulic power flow through the pipes. The flow limited by the size of the pipe, and the torque of the turbine circuit is opened or closed by the valve. The valve parallel pipes in the water turbine with the pipe and the central fuel pump back to the valve. The electrical power shows the electrical circuit to it, which shows the switch, the parallel wires going into the motor and through going through the generator back to the switch. Electrical power flows through the wire flow limited to the size of the wire. Torque of the motor circuit is open and closed by switch. 117, current. An ampere is the rate of electric current. Technically, is the flow of the current deposited the specific weight of the silver with the standardized silver and nitrate solution under prescribed conditions in 1 second. 118, Ohm's Law. George Simon Ohm, a German physicist, created the electrical formula known as Ohm's Law in 1827. Ohm's Law states the relationship between the voltage, resistance, and current. In the simple closed circuit, fixed resistance current, but the circuit is equal to the voltage divided by the resistance. Resistance is represented by R, the E is the voltage, and the current by I. The formula is known as I equals ER. I equals E divided by the energy in the current divided by the resistance equals, the voltage and divided by the resistance equals the current. Like I said, you can change the variables on that. 19 symbols. Any electric used in standard symbols to represent the various parts of the electric circuit. The most current frequently used in locomotive circuits are shown in Figure 111. The symbols represent a basic part of the apparatus installed with a separate symbol for each of these pieces of equipment. For example, the coil of a ground relay, while wheel slip relay, field shunting relay, always represented with the same symbol for operating coil contains, and contacts are always represented with the same symbol of contacts identified with the separate pieces of the equipment. The drawing symbols are accompanied by the letters which, such as GR stands for ground relay, WS stands for wheel slip relay, and actual wire diagrams, the location of the parts of the circuit shown in the true relationship, a schematic wiring diagram. All parts parts are shown, but not necessarily in the true locations. 120. The schematic wire drawing. The schematic wire drawing for a locomotive is very much like a road map. The lines are used to show the electrical circuits, highways, symbols used to show the devices in circuit cities. For example, electrical map having to tracing out of the circuits and locating with the trouble of on the locomotive. Unlike the automotive trip, maybe or may not intend to where it started, electrical won't start unless they have complete circuit back to its source of generated battery. All right, from the top down, and from on the left column, and then we'll go to the top right column. Generator motor arm, the cooling generator field motor, field relay, and contactor is a zigzag. The drum type looks like a key, like a bit like a puzzle piece. The interlocking normal opening and interlocking normal close shows it looks like a switch, but with a butted plate. The plus negative with the dash lines in between it stands for storage battery. The fuse, it shows the amperes, the number divided by the A amperes. The fuse is drawn like a switch, but with an S curl. The ammeter with a shunt is done with looks like a normally interlocked with the A over top of it. Your seldom reflector is pretty much a triangle with a line. Your light receptacle is a circle with a double line in it. A bullet hole is a battery charging receptacle. A circle is a light. And series fields are done by humps or column fields. The reverser shows a reverse and forward, and reverse parallel track. The rheostat is an arc with a parallel switch in the middle. A switch pole knife switch is across with a cross the line like a door hinge. The double pole knife switch is a double door hinge slash Christian cross. Single pole snap switch is a door. This is like a little door swing. The double pole snap switch, also the double parallel lines, both switches snap at the same time. A push button shows the switch as a lever, kind of like a interlock, normally open, like lap kind of gimmick. Push pull switch, also likely. All right, the blocked line or the squared line shows the fixed resistor. A variable resistor has a parallel current through the middle of it to the one side of it of a field resistor, a blocked or squared off line. The endpoint with a circle of the dash through it says the negative side of the battery. Also, the wire ground is a triangle, a pyramid made out of just dashes on the bottom with the end of the line. Wire ground of the locomotive. Wires connected are shown by dots. Capacities are closed doors. Circuit breaker also comes with a fixed resistor, your amperes, and a push-pull switch. Look at the schematic drawing of the fuel pump circuit of the figure 112. Trace out one of the highways for the electrical map. Here you see a battery, a fuel pump contract coil. Its contacts, a fuel pump motor. A symbol A is in standard for the motor armature. All switch and contacts are shown on the normal position that it was in power on. The job of the fuel is to pull the fuel out of the tank, deliver it to the engine. It shovels the coal into the engine. The first step of the starting of the pump to close the battery knife switch. This connects the battery positive with a 50 wire, but though 50 wire is not hot, nothing will happen because there's no path from it to the 4-wire battery negative. So next, close the fuel pump switch next and make such a path. The current can now flow from the 50 wire cut through the switch in the fuel pump contactor coil to the 4-wire. The current flows through the coil to the set up the magnetic field, closes the contactor. Now there's path from the 50 wire down for the fields of the armature of the fuel pump motor to the 4-wire. Current flowing through the path, it starts the motor and then drives the pump and then furnishes the fuel to the engine. The figure of 112 shows the schematic of the wire drawing. You see the battery positive and negative side on a single open switch. These are parallels. It's kind of like They made 50-50 in the center. Um, when you have a parallel, think of fractions like in the middle, like factors, and come up with a common factor. They will equalize in the middle if they're parallel. The at 50% in the middle, it goes to another fuel pump switch, which goes on the inside of the fuel pump's parallel switch 1. We'll call it the fuel pump contactor coil, which goes back to the battery negative. Also, from the other side of the split at the parallel connection, goes into the fuel pump contactor switch, and then to a series of fields, or into the shunt field with an A field, and from the series of fields, fuel pump motor, and then goes back to the negative battery return. In a simple diagram, the figure 112 parts of the circuits are identified by the names as well as the symbols. Often than not, however, the only symbols are used, mostly known by anyone attempting to trace the locomotive circuit. Alright, power equals work divided by time. 121, work and power. Work and power are often confused. Work and the result of the applied force. When results in motion, the product of the force of the time distance among which is moves in work for is equal to force time distance. Work of the power, the rate is doing the work has the element of the time. The work does not. Power equals the work divided by the time. The work is expressed in foot pounds, while the power is expressed as foot pounds per second. Work done by the body result increase the potential energy, kinetic energy, heat, and of friction. In the illustration shown in Figure 113, energy is contained within the bucket of water. Potential energy is possessed and becomes the water position since the since the bucket of water is 10 feet high and the 20 pounds of water, the potential energy is 20 to 10 at 200 foot-pounds. The water runs down the pipe toward the pump and it becomes the kinetic energy. There's energy in motion. The 20 pounds had to moved in the horizontal line of the 10 feet. No more than 200 foot-pounds of work could have been done. Since potential energy of the water has not changed, the work has also gone into heat of friction. 122, measuring current. An ammeter is used to measure the quality of the current flowing in the circuit that connected to either the main power generating circuit and or one of the traction motors. If in lateral prevails, other traction motor circuits carry on the equal amount of the current. The ammeter is equipped with the shunt and bypass, carrying most of the current and total current load pass through the ammeter or its shunt. The shunt is designed to work with the ammeter so that the relation between the current flowing through it and the current flowing through the coil of the ammeter, the pointer is attached to the coil with the turn against the spring, so the deflection is proportional to the current. The dial over which the pointer swings can be marked to read amperes, or quantity of the current flowing. In addition, with the having figures shown in the current, the amperes of the ammeter may be marked with the minutes, indicating the maximum time a locomotive be operated with a certain load. This shows the bucket of water illustration with a bucket of water of 20 pounds up to 10 feet. Motor of the pump, the water tank, a bucket of water being pumped into 20 pounds at the drop of 10 feet, and also 100 feet. And also shows the foot as 100 foot. Is part 3. Measuring for voltage. The voltage is measured by the voltmeter, which moving the coil moves a high resistance and avoided by the short circuiting of the voltage. Therefore, the coil is connected with a series of resistance. No shunt is permissible. The voltmeters are connected across the load. This is distinctly different from the connections from the ammeter, which is connected in the circuit. Since the voltage has been linked to the pressure, the voltmeter can be compared by the pressure gauge. It should be the gauge. It should be noted that neither the voltmeter nor the pressure of the gauge has anything to do with the main flow. The voltmeter must be connected across the line, across the load. A significant difference in the appearance of the voltmeters and ammeters is the ammeters have heavy terminals to which the wires are connected, and the positive and negative connections are designed on the voltmeters as well as on the ammeters. 124, overloads. The greatest damage likely to come from overloading of a locomotive is overheating the traction motors, which is heat generated with the motors equaled by the rate at which the heat is dissipated with the continuous rating attained with the ammeter induction, and graded with the continuous rating as an overload. Since the motor itself can be absorbed, some of the heat of the cold motor will cause the overloading condition as quickly as the warm motor, whereas the motor has been operating with a continuous rating limiting for a long time does not have overloading capacity at all. Wiring built to carry the certain load of the current by the heavy current load occasionally imposed on it. Overloading, and if allowed in the wiring, can damage insulation and equipment. Overloading, protecting the provided with devices such as fuse, circuit breakers, the breakers of the circuit before the damage occurs. The fuse is inserted with the circuit, carries the full load of the current. It has a low melting point, and when the current becomes excessive, the melts and it opens the circuit. Since it operates the melting, the fuses can only be used once. The circuit breaker permanent fixtures consist of the switch that is open with a magnetic coil when the current in the circuit is reaching the danger point. 125. The Domino. The dynamo is a machine that converts mechanical energy into the electrical energy into the mechanical energy. When the output of the mechanical dyno is called the motor. When the electrical generator, the motor have the same basic construction. Either may be called the dynamo. A dynamo is a reversible capable operation, either the generator or motor. The basically dynamo consists of the field and a stationary coil with the armature rotating coil in the locomotive field. With the dynamo consists of the magic poles faces bolted into the frame, and the coils wound around the field poles are called the field coils. The amount of the current in the coils determines the strength of the magnetic coil, the magnetic field of the flux of their poles termed with the field excitation. The stationary pole and the frame are called the stator, and a rotating coil which carries the load of the current. This is called an armature or a rotor. The definite relationship exists between the direction of the field and the direction of the motion, and the direction of the current. The directions can be determined by applying the Fleming's right-handed rule, the generator, the left-handed rule for the motors. Fleming's rules originated with the English electrical figure 114, a left-handed motor rule. Engineering Sir John Ambrose Fleming in 1849 through 1945 looked at the left-hand rule illustrated in figure 114. The thumb points in the direction of the motion, the forefinger points in the direction of the field, and the middle finger points in the direction of flow current. The right-hand rule for the generator works the same way. You see the motion, the field, and the current shown in the left-hand motor rule. 126. The generator, the valve of the electrical motive force, the EMF produced by the generator, is related to the amount of the change of the field motion or to the rate of which lines or magnetic forces are cut into by the armature. The electrical motive force is a single armature coil, varies even with the armature speed, but the rotation remains contained. Looking at the figure 115 shows the armature cuts across the more and more lines of the forces approaches 90 degrees. At 20 degrees, for example, one line has been cut at 40 degrees. In the same period, the four more lines have been cut, and the EMF varies with the number of lines that are being cut by per unit of the time 0 to 0 degrees, maximum 90 degrees. At 180 degrees, the EMF is again 0 between 180 and 360. EMF is opposite direction and given the name alternation current, describes simple alternating current AC generator. Figure 115 shows the relationship of electromotive force and speed, the negative and the north and the south, at 360, 0 to 20 degrees, 40 to 60, and 90 degrees at the north and 180 degrees. Brush's generator motor should be set at the point of 0 of the EMF, a point of occurring at approximately halfway between the main poles. Unfortunately, self-induced EMF exists at the coil at the neutral point, and the brush is at the fringes of the flux, so that it's difficult to obtain the satisfactory commutation. The most satisfactory solution has been to introduce separate flux to produce the desired flux density in the neutral zone. This is done by small poles called interpoles located between main poles. Filled armatures, cores of the build-up of the layer sheet and steel to reduce the strap of the currents called the eddy current. Since the iron are almost as good as the conductor, electrical currents tend to flow almost readily in the iron as the copper, lacking in the outside. However, they'll circulate with the cores generated with the excessive heat resulting in the loss of power. The heat must be much less than the laminated core than would be the solid core, because the laminations provided passage through which an air circuit carries away the heat. The armature coil is connected with either lapping windings or the wave windings. Coils are lap windings overall. Coils are in lap windings overlap each other and are connected in parallel, while the wave winding in the series around the armature voltage is high, but the current is in lower lap wound coils and wave wound coils. E. Alternating generator and an AC generator illustrated with the figure 116 ends the rotating coils connected with the continuous metal rings called slip rings, mounted on the axis armature shaft, insulated from each other metal and the carbon blocks called brushes ride on the rings through the contact with the external circuit. The number the complete with the wave cycles generated per second is called the frequency, determined by the speed and design of the armature. The generator EMF is affected most of the change in speed, rotation, armature, change of the flow density, and changing the current of the flow and field coil over by using variable resistors, changing the size of the field, the size of the turn of the rotating coil. Since the current of the armature is alternating, some of the method must be used to change it in direct current between the entering the outside of the current circuit. This is done by commutative. The commutative reverses the connection of the coil to the external circuit. At the same time, the EMF reverses the coil. The alternating circuit in the generator becomes a pulsating direct current when it reaches the outside circuit. This shows the alternating current generator. You see the output to the load, the brushes, and the collector rings. The direction of the rotation with the back connection, and the coils from side to side, coil sides. Direct current generator, the direct current supply directs to the preceding paragraph, not particularly in commercial use, but because the voltage reaches zero twice in each revolution generated with the power output would be too small. A particular generator must therefore may have many coils, each coil being connected to the pair of the commutator segments, as so the output of the current from the overlap provided for the continuous flow of the direct generator is one of the three types depending on whether the fields are connected in series shunt combination of two. A series wounded generator has field winding in the series over the armature, and shunt wound generator has field in parallel with the armature. Compound wound generator has both. See the alternator. An alternator provided with some locomotives to supply the AC power to the fans and blowers. The stator contains the two-phase output winding. The fields are wound in the rotor. The field current is supplied by an auxiliary generator, a non-voltage relay connected with the output circuit, giving the protection against failures of the AC power. A fuse and circuit breaker in the line supplying with the alternate fields, and if the current is open, there is no AC power to the alternator is attached with the main generator frame, and it is driven at engine speed with the main generator shaft and voltage frequency alternator current speed of the motors fed with the alternator through the vary with the engine speed. 127 power transmission system. In the engine of the diesel electrical locomotive is an internal combustion engine. Relay of the forces begins with the push of the piston and the power stroke. The piston forces the travels when the connection rod to the crankshaft, which transmits the rotary drive. The crankshaft are counterbalanced, designed to ensure that even of the smoothness of the distance of the force through the shaft. Up this point, the power relay with the power mechanically. If the locomotive was equipped with the gear transmission, the relay would be mechanically throughout the gears and transmission, similar to the automobile. In order to largely enough to control the locomotive, would be too large, too bulky, and to be practically a transmission omitted through. Therefore, in favor of the wires form of the electrical transmission. These wires lead from the generator to the traction motors to change electrical power back to the mechanical power. Motors are mounted on locomotive trucks. On some locomotives are geared with locomotive axles. About half of the weight of the motor is supported on the truck frame through the nose of the motor frame, and on the other half of the bearings of the driving axle. E. The electronic transmission. The task of the electrical transmission system is to receive mechanical energy from the engine, convert it into electrical energy in the generator, transmitted by the wires through the controllers to the relays of the traction motor, which changes it back into the mechanical energy at the wheels. Complete engine generator is called the power unit. Some of the locomotives have two or more power units, each requiring fuel, water, oil pumps, radiator fans, blowers. Besides the main generator, there is an air compressor auxiliary generator, also powered by the engines to supply the engine starting equipment, air brakes, pneumatic controls, and low voltage light and power circuit. B. The generator and traction motor in the diesel electric transmission. The generator is mounted directly to the engine crankshaft. Auxiliary generator is coupled to the main generator, driven by a belt. One or more traction motors. The reduction gears are mounted on the driving axles of the trucks. Final of the reduction gears are located between the traction motor and the axle. No mechanical parts are needed to reverse the engine as necessary with a total mechanical transmission system. The power produced by the generator is converted by the traction motor and mechanical driving force at the wheels. The motor can be produced very high torque at the start of which it decreases the load on its increased adjustment. The generator fields of strength and made with the regulator introduce the resistance into the circuits as indicated by the governor. The governor acts on the valve which controls the oil under the pressure in the cylinder. During the increase of the engine loaded with the governor's piston rise of the fuel is indicated by the contacts and close causes the motor to rotate the opposite direction and reduce the resistance into the circuit. The traction motor is cooled with the filtered air force in either electrical or mechanical. Electric method is preferred because it provides a full blast of air at all speeds, while the mechanical system blows the slow speeds with the highest electronic current in the motor. C. The connecting gear ratio. Ratios of the gear connecting with the motor of the axle selected on the basis of the service locomotive is to perform the high-speed service of the such as passenger service call for ratio which keeps the motor speed when the power is more important than the speed, such as the freight service. The ratio is used only requires many revolutions motor for an on-site movement of the locomotive. Intermediate ratios are used in the general all-purpose services. The gear ratio expressed by the two members, one of the number of the teeth in the axle-mounted gear, the other number of the teeth of the traction motor pinion. For example, if the axle-mounted gear has 60 teeth and the traction motor pinion has 17, the gear ratio is 60 to 17 or 3.53 to 1. The main generator shown as in Figure 117 converts the power out of the diesel engine into the electrical power of the operation traction motor. The director continued to the diesel engine. Generated speed varies with the engine speed. The generator self-manipulated by a fan may move down a shaft. The main field of the generator is supplied with the battery by an exciter controlled by the load generator. The different field in the series with the generators wound to oppose the main field with the purpose to verify the total field strength to constant kilowatt output. Other fields, such as starting fields, are used when cranking. The main pole piece of the generator are laminated steels riveted together, bolted with the frame. The field coils impregnated, baked with the insulating compounds to guard against the movement, chafing with the coil, and to permit the flow of the heat of the surface. But to withstand high speed and vibration, the armature of the generator balanced both motor before and after winding to reduce the vibration is supported at one end of the anti-friction bearing and the other engine of the at the engine crankshaft. This is a pretty bad drawing of the main generator. 129, the traction motor. The similar generator, the direct current, such as the traction motor, can be connected with the shunt series. The shunt motors are used at the constant speed. The desired output of the mount motor varies with little of the changes of the load. Series motor has been good in the traction, but always be connected to the load, otherwise will be sped up so fast that they will be damaged. Traction motors are series wound directed current motors geared with locomotive axles and wheels, shown in Figure 1.1, Item 33. The converting the electrical energy with the generator's tractive effort to the mechanical energy. Half of the motor's weight is supported by the truck frame, half of it on the axle. The motor of either the connected permanently in the series parallel arranged with the transition from the series to series parallel connection. The armature turns the roller bearings into the motor housing the axle bearing of the split sleeve. So the type of the traction motor fields are provided with the shunts which divert the portion of the field current with the motor's cannot absorb the full power output. The field shunt contactors can be operated pneumatically, magnetic valve by electric relays. The relay operation is one of the easiest to understand. Relays open and close certain generator voltages, close the field shunt contactors, and permit some of the current to flow through the shunts and weaken the fields. Blowers are provided with large locomotives to force large quantity of cooling air through the traction motors, thus preventing them from overheating. The locomotive must not haul a train unless the traction motors are adequately cooled by the heat generated with the heavy currents will damage the motors. If it is not carried away, the blowers are mounted on the floor through the locomotive, and ducts are carried the air through the underframe of the motors. They may be mechanically driven by the engine and electrically driven. 130. The exciter supplies the main generator with the field current. Is in a small generator that maintains the power output of the nearly constant as possible to avoid overloading the engine. The strength of the main generator field must be verified so that the generator voltage is decreased as the current demand is increased. The exciter's own field is supplied by several sets of windings, which in the independent each of the other. One set of the windings is a 4-pole field energized by the battery auxiliary generator. The strength determined by the load generator installed with the circuit. Another set of windings is 2-pole field by the exciter and armature. The 3 set windings is differential, reversed, and field with the energized current with the main generator. When the current from the main generator to the traction motor is high, the differential field opposes the other exciter fields and reduces the exciter output. 131. Load regulator. The control power output of the main generator is known as the load control. Load is imposed on the engine. The governor emits more of the fuel into the fuel limit the most speed is reached. An attempt to increase the load beyond the point it will cause the engine to slow down. At such a time, the load regulator generator excitation circuits automatically reduce the power output by the generator, reducing the field's excitations. Diesel engine continues to run at normal speed. 132. Reverse, shown as the later figure shown in 217. The electro-pneumatic switching device will reverse the direct current of the traction motor field windings where the fields are reversed. The traction motor changes the direction of rotation, thereby changing the direction of the travel of the locomotive. The main switch element of the reverser is the rotating drum. On the surface of copper segments of the contact different combinations. The sliding fingers of the drum rotates magnet valve to the reverser fed through the interlocks of the main power switches to keep the reverser from turning except when the power circuits are open. When the magnetic valve explained in paragraph 134C is energized, air is supplied from the pneumatic mechanism to turn the drum, establishes the proper electrical connections. If the coiled magnetic valve is burned out or if the air supply fails, the reverser may be thrown in manually by depressing a button on the magnetic valve. If the engine is dead, the drum can be turned by hand. 133. Cutout switch. Traction motor cutout switch is used to take the motors out of the circuit. This is the electrical failure to the circuit, such as short circuit ground. Three types of cutout switches are used. Toggle switch in each of the motor circuit. The multi-pole rotary switch with the controls all motor circuits. The contacts mounted on the reverser. The rotary toggle cutout switch is the control circuit to the main power switches passes through the traction motor cutout switch. With the cutout switches open, the main power switches are therefore open, corresponding with the motors are disconnected with the generator. The switch setting should not be changed under the heavy load because heavy currents are likely to arc and burn the contactors. Before opening a power circuit, idle engine by a throttle or by isolating switch. 134. Main circuits. Power of the main generator is carried by electrical cables of the traction motors, which are generated by the driving axle. The main power circuit is the path of the current flowing of the generator through the cables of the motors back to the generator locomotive through the three types of the circuits of the series, the parallel and series parallel. The series of the circuit, same current passes through each of the devices' connection with completing its path. The source of the supply total resistance of the circuit is equal to the sum of the resistance of all the portions. A parallel circuit of the current of the source divided by the two or more parallel paths turn current. Total current from the source of the equals the same sum of the current in the parallel path. The resistance of the parallel circuit allows the resistance of any of its individual parallel paths. A series of Christmas tree lights in which all go out with the one burns out or opens the circuit is a familiar example of the series circuit with each of the bubbles standing on only in the portion of the voltage of the house circuit, the lights of which other bulbs continue to burn, which one burns out of the parallel circuit. Each bulb operates with a house voltage. If the motors are connected with the same manner, the lamps in the same circuit, the characteristic applies. The difference in operating characteristics of the motors, different voltage, and chief reason for the relative greater number of the methods used in connection traction motors. Many different designs of the main power circuits are used. Each circuit is independent of others except for the small wires with wheel slip relay connections. Many locomotives permanently joined with the series of parallel. The tie between the motor circuits exists when the portion of the circuits is serial parallels. If the no contactors are used in order to fully generate the voltage applied with the motors in series connections, the contactor will closely try the circuit. In the use of the contactors will open the circuit in from the main generator. In the electric drive, the power from again be given varied by the throttle adjusting the voltage current and tractive effort. When the throttle remains in the first notch, the current amperage decreases rapidly because the motor with increasing speed developing greater counter voltage, and the throttle is moved to the higher position. Fuel supply is increased. The engine and the generator can deliver more power when the throttle is advanced as far as possible. Engine speed and the generator voltage are at the maximum. Various devices are used to change the connections of the circuit. The most common is the contactors, interlocks, magnet valves, relays. The contactors are switch used for the opening and closing circuit. The circuit which are the current and load. The contactors are magnetically operated, are energized by the current of the battery. The magnetic brings the movability contact in the touch. When the fixed contact of the main circuit, when they are not being used, the spring pulls the movable contact away. When the contactor uses the traction motor circuit, it has to be handled with a heavier current, but the contact tips must be pressed together tightly operated with the compressed air, and they are called pneumatically contactors, although they use magnetic valves. When the operating circuit is closed, the current flows through the coil and it moves the core of the magnetic attraction, and this movement opens the air valve. B. The interlocking auxiliary switch is designed to control the connection breaking circuits operated. Another switch, perhaps in the contactor involved in the interlocks, called in. Interlocks closed with the mains closed switch are called out. Interlocks closed with the main switch open. C. A magnetic valve consists of a magnetic coil core action upon the air valve. The coil is a low voltage control circuit connected through the interlock of the valve. Automatic controls, manual controls, the same manner as the coil of the coil of the contractor. Usually returns to de-energize the position of the spring action of the valve of the coil. Are used in such applications: shutter control and the compressor synchronization sanding, as well as reversers and pole switchers that pull built-in portion of the equipment. D. A relay of small magnetic electrical consists of the coil, several small contacts, changes the connections in one part of the circuit and is a response to change that take the place of elsewhere in the circuit. The relay coil may either have high voltage, low voltage circuits on the locomotive operating in much the same way the contactor relays are required to carry the heavy current, generally with the smaller. They may be adjusted to open, close, various voltage responding operating conditions, which contacts the relay close. The close of the circuit of the coil contactor magnetic valve controlled with the relay. More than one contactor in the magnetic valve can be controlled by the relay building of the relay and several sets of the contacts. Relays are used miscellaneous purposes, are named according to their purpose served. They are basically alike with the construction operation. Two of the most common are the ground relay and wheel slip relay. One, the ground relay, illustrated in Figure 118. Ground relay is illustrated in the main power of the circuit to warn if the ground develops in the circuit of the ground. If the current flows to the relay and is contact with the closed circuit with the alarm bell with the indicator 1, the ground relay cutout switch. 2, the reset button. Figure 118, ground relay light. In most locomotives, it also idles the engine, disconnects the traction motor. In multiple operation, indicated lights as only action extends to the other units. As reset button is used to release the relay. Cut out the switches must be provided to make the relay entirely operative. 2, the wheel slip relay and indication system. Using the wheel slip relay frequently installed on diesel electric locomotives, the system relay is connected with the resistors in the traction motor circuit. If a pair of wheels slips, unbalanced voltage causes current to flow through the relay. The relay is activated with the contact the energizer governor solenoid with reduce the engine speed, operating the warning buzzer indicated light, both the engine cabs and the interlocking reducing generator excitation at the same time. When slipping stops, the balanced voltage again exists. Power in the automatic restored, but the buzzer light and transmission to all units in the multiple engine speeds is reduced only to slipping unit. 135. The main power switch is the power contactors connecting the traction motor to the main generator. They are pneumatically operated heavy-duty single-pole switch is located in a high-voltage electrical equipment cabinet. The contactor, sometimes called the unit switch, the pneumatic power switch consists of one fixed and one movable contact, a magnetic valve, an arcing horn, an arc box, and a blowout coil. When the throttle is in advance to the first notch, the magnet valve admits the air to the cylinder, moving the piston to the closest contacts. When the magnet valve is no longer energized, spring action, the piston opens the contactor. The contactors normally open. The traction motor current has dropped in negligible quantity. The provisions must be made, but the interrupting heavy current when the contactors have to be opened under load, as during the emergency brake application. The equipment of the interrupting heavy current consisting with an archive warn carrying the current, the arc box confining with the arc and blowing out the coil, by which the magnetic field of the coil forces the arc away from the arc tips, and the arcing building up the current at the contact tip points, and the concentration of the current caused by the collection of the matters of the contact. The current burns the contact, destroying the serviceability while interrupting the equipment. The path of the arc increases the length and difficulty of the jumping of the gap, increases the current, and current stop flowing. 136. Engine starting circuit. Activated with the starting button. The operator panels the starting of the circuit. Provides the power with the starting of the engine. The start button closes the starting of the contactor. Uses connecting the storage battery to read the main generator starting. The contactors consisting of the coil operated main contacts carrying the heavy starting current. Small auxiliary contacts used to interlock with those generated with the field circuit. Close first and followed with the contactor generator armature circuit. If this sequence were not established, the armature would short circuit with the battery. When contactors closed, interlocks on the contactor control sequence automatically when the start button is pressed. The fuel supply system must function be functioning. Since the lubricating oil pressure does not exist, shutdown engine, the starting switch related connections must interlock to prevent the fuel shutdown until the lubrication oil pressure builds up. The main power controls may be interlocked off position of the stop of the power of the flow. The engine fires since the low voltage of the main generator is too high for the control circuit immediately or after firing. The starting circuit must be opened automatically. 137. Power control circuits. The control circuits are low voltage circuits that control the switches necessary for the handling of the high voltage power circuits. Typical control circuit is manually and automatically operated. Power is generally fed through the master control switch from the source. The operating oils in the switches appear to the negative return line for the control switch. The immediate equipment between the control switch and the operating coils consists of the manual controls, automatic controls, interlocks to determine the switches are energized. 138. Transition. In automobile, gears enable you to vary your use of the power being put out. The engine, for example, does make it possible for use to going up steep hills and slow speeds, but gears are large enough to give the same effect of the locomotive, but would be much too large practical. Another method of using called transition, a varying of the power put out with the generator. The amount of the current required for the traction motor constitutes the load for the generator. By the controlling the generator field power taken from the engine can be regulated. Increasing the field current increases the power delivered to the locomotive. Decreasing the current decreases it. Connecting the motors is parallel. One of the two main methods of transition diesel electric locomotive. The other is shutting off the part of the current drawing in the circuit, forcing more of the current to the drawing from the generator to replace it. The transition then accomplishes the changing of the traction motor for the series of connection to the series of parallels or parallel connections by the closing of the field circuits, weakening the traction motor fields. When the motor is connected in series, the same of the current flows for either the motor, the generated voltage, and press on the entering the group of the motors, resulting in comparative low voltage for each of the motor. The connections are charged to put the motors in series, parallel, or parallel within each other. High voltage and press for each of the motors, resulting in the corresponding increase for the power output of the generator. The fields of the series motors are shunted. Only portion of the current continues for the flow of the fields, with weaken the field of the counter voltage back electromagnetic forces. The equivalent to lowering the resistance of the circuit results in increase of the flow of the circuit, increase of the current every instance increases the torque, tractive effort, and the power drawn from the generator. A balanced condition of voltage, current, and tractive effort is reached at progressive high speeds. Hand-operated transition controls are in use, but in transition used automatically when original connections are made, but the opposite sequence of speed decreases. The process is called backward transition. 139. Dynamic braking. The braking of the brake shoes put where both the shoes and the wheel. The friction of the shoe pressing against the wheel causes extra heat. The dynamic braking, the disadvantage eliminated. But the locomotive is coasting to the stop. The engine man can cause the traction motors as the generator slows the locomotives without using the brakes. During the dynamic braking, the traction motor connection are changed. The motor acts as the generator, sending the current to the resistor, dissipates the energy into the air. The amount of the braking is regulated by the changing of the field excitation of the traction of the motor. Controlling are built in the throttle and reverse levers. The dynamic braking system is an independent of the air brake system, which may also be used on the train. Military diesel electric locomotives are not equipped with dynamic braking. They use only the air brake system. 140. Pneumatic control switch. When the emergency brakes are equipped under similar conditions, the energy power reduces pneumatic control switches. That opens when the brake pipe is produced, and the opening of the switch stops the engine, stops the fuel, and turns on the indication lights. The throttle is returned to the idle, and the brake pipe pressure is restored with the switch reset to itself. 141. Locomotive controls. Most of the electrical equipment of the locomotive is mounted on a centrally located cabinet. The operator control station is located in the cab. Shown in figure item 8 of figure 1.1, locomotive movement is directed to the series controls, throttles, reverse, transition levers, automatic independent brake valve handle, transition, forestalling switch, and control switch. Either the throttle lever, the throttle controls the speed of the diesel engine, consequently power delivered by the traction motor, and the throttle functions with pneumatic, electro-hydraulic governor that is called the electrical throttle. Must be connected with the electrical to the governor. One of the functions of the air system is called the pneumatic throttle and must be set with the governor through the pneumatic actuator. Some of the locomotives have mechanical linkage between the throttle and the governor. The typical electrical throttle has 7 to 8 running positions. In addition, with stop and idle, the throttle idle lever is moved in its operation range. Various electronic connections are made through the low voltage control lines and the solenoids in the governor's fingers, making the sliding contacts of segments of the rotating drum cylinder in the throttle throttle, determining the fuel setting of the governor. The throttle is also interlocked mechanically with the reverse and with the transition lever, and if its transition is controlled manually, the features ensure the opening of the main power switch if necessary during the various stopping the reverse operations. Two pneumatic throttle is equivalent to the pressure regulating valve responding to the pressure established in the throttle. Pneumatic actuator determines the fuel setting of the governor. As a pneumatic throttle, the auxiliary contacts similar to those of the electronical throttle for the sequence interlocking features and multiple unit operations on the airline, furnishing air pressure equal to the control of the reservoir pressure is required between the units. The reverse lever. The reverse lever controls the magnetic valve of the reverser, which turns the drum to change the connection of the traction motor fields. This lever must not be moved when the locomotive is moving because the circuit may be shorted. If the locomotive is unattended, the lever should be taken off. If the locomotive is unattended, the lever should be taken off the control stand in order to interlock with the control in an inoperative position. The seventh position of the reverse lever, sometimes called the controller, is used only manually in controlled transition type locomotives instead of a transition lever. The transition lever ordinarily the transition lever is provided with locomotives that have manually controlled transitions. It may be installed in locomotives to automatic transition in order to control the circuits during multiple unit operation. Locomotives have manual transition, a braking position, dynamic braking, sometimes provided because of the definite relationship between the current speed and the proper set. The step transition is usually indicated with the dial and load ammeter and speedometer. The automatic brake valve. The automatic brake valve controls the operating of the brakes on the locomotive on the cars that when they are properly connected. The independent brake valve controls the operation brakes on the locomotive only. In transitioning forestall switching, the transition forestalling switching of the control panel is used to prevent undesired forward transition automatic equipment. Backward transition is desired to operate in backward transition relay, reducing the throttle to the idle position. F. The control switch. A switch usually coupled with the control switch connects the control circuit to the source of power. All control except those from the locomotive lights. In some models, engine starting the circuits are normally fed through the switch through the interlocking wheel. Setting the dependent on the switch is therefore equivalent to the master switch of the locomotive controls on both leading locomotives and any other trailing locomotive to which the controls are connected in multiple unit equipment. When locomotives are connected but their power systems remain independent, the process is known as double heading. However, the electrical connections are made, all locomotives are controlled from one cab. It is called multiple unit operation. Equipment for the connection units. The multiple consists of the jumper, the following, the control wires, the control switch, the forward, reverse of the control, the throttle standing alarm indicating circuits, emergency shutdown switches. The wires are connected to the plug, which is keyed in some way that can be inserted in the end of the receptacle of the locomotive in the correct position. Only the locomotive from which the operation is controlled is called the leading unit, and the others are called trailing units. Only the trailing unit engines are started and battery switches are closed before operation begins. Auxiliary power system. The auxiliary power generator is used to charge the storage battery and power to low voltage circuits. For lighting and control equipment, the fuel pump motor and the field excitions. It may be driven by belt or gear from the shaft, either from the engine or the main generator. Is usually mounted on the generator's frame. The auxiliary generator assumes the load after the battery has been supplied power from the starting of the engine. A breaker type switch of the fuse disconnects the auxiliary generator. If it switches and fuses open, the batteries must supply with the low voltage requirements. Many of the locomotives also have auxiliary generator field switch. It is open, but the locomotive is shut down and kept only open until after the engine is started again. And on the locomotive that had both of these switches, the field switch cabinet is an equipment cabinet. Voltage regulation. The auxiliary generator output is regulated with the changing of the strength. Auxiliary generator field is sped with the auxiliary generator increase. The shunt field strength must be decreased to maintain the consistent voltage. A regulator may consist of a small torque motor or the relays to the sensitive change in the voltage movement of these elements change the resistance of the field circuit. The operating principle of the voltage regulator is the voltage generated with the proportional to the shunt of the field strength. The voltage regulator increases the resistance of the field, thereby reducing the flux in such an external condition of the generated speed, load, and internal shunt field resultant resistance can cause the change of the torque of the torque motor armature. Armature will move the sectors such a direction to cut short field resistance in and out, and the reestablished setup voltage at the same voltage for every position. The battery system storage battery supplies power from the cranking of the engine, also and supplied to control the lighting circuit before the engine is started. The engine starts. These circuits are drawn by the auxiliary generator of the batteries beneath the underframe, beneath the cabinet floor and cabinet compartment next to the cab. The switch is in the electrical cabinet and nearby the panel connecting the battery to the auxiliary generator controlling the circuits. The battery ammeter indicates the rate of the charge of the discharge of the battery. It should indicate the zero, the charge of the reading of the engine is running. As soon as the engine is cranked, the auxiliary generator starts with restore the current of the ammeter. This should register with the charging of the current until the battery is charged. The battery may also charge with the shop circuit to the terminal yard circuits through the external charging receptacles. When the engine is shut down with auxiliary generator, voltage drops to a low charge of the battery. The reverse current of the relay opens the battery contactor between the auxiliary generator and the battery, preventing the battery from discharging back in the auxiliary generator windings. 144. The summary. Measure of electrical pressures, resistance quantity called volts, ohms, and ammeters. The volt is unit pressure leaving the generator of the battery. An ohm is unit resistance of an ampere is used to the unit and measure the available of the receiving mechanism, such as one of the traction motors. Ohm laws states the relationship between these current equals voltage divided by the resistance voltage measured by the voltmeter, amperage by an ammeter. The wiring diagrams use the line standardized symbols, abbreviations using tracing circuits. The local aiding troubles of these electrical locomotives. Wiring electrical system is built and carry the specific load of the current heavier than the specified. It's called an overload. Since an overload of the wiring can harm the equipment, fused circuit breakers are provided to break the circuit before damage occurs. Mechanical energy can be charged into electrical energy, electrical into the mechanical, and by a dynamo. The mechanical energy is changed with electrical. Dynamo is a generator with the electrical energy is changed into mechanical. The dynamo is a motor. The generator can be either the electrical alternating or directing current type. The current is set up with the generator armature coil. Whenever the coil cuts across the lines of the magnetic force between the generator poles with an alternating current generated, the current flows through the coil first one direction from the other unless the generator is accumulated to the alternator current and direct current. The generator main coil is connected from the closed circuit. The direct current is applied with the direct current. Generator coils can be connected in series of shunt in combination series of shunt. Like generator motor can be also connected in shunt series. Traction motors are series wound and direct current motors as provided with a shunt. The function is to convert the electrical energy with the generated mechanical force for the locomotive wheels. Because the locomotive size and weight and the gears are large enough, the control would be large, bulky, practical mechanical gear transmission of the power with wheels, therefore replaced with electrical transmission change of mechanical force from the engine into electrical power generated operated with the engineering crankshaft. Wires from the generator transmit the power to the traction motors. Traction motors turn the wheels. Electrical circuits in the locomotive are connected in series or parallel or serial parallel connection. Combination of the two. The circuits are obtained and closed in the contactors operated with the compressed air heavy circuit of the current by the battery and circuits where the circuit is low. The auxiliary switches to control the connecting and the breaking of the circuits called the interlocks. The relay device to change the connection in one part of the circuit. The response to change can take place in another part. Changing traction motor from the series of the connection to the series parallel. The parallel connections is known as the transition can be done with the connecting of the motors parallel to the shunting off the part of the current of the drawn into the circuit, forcing one or more of the current to be drawn in the generator. Traction motor cut out, and the switch uses the traction motor out of the circuit. If there is electrical failure, dynamic braking locomotive wheels are used to drive the traction motors while acting like a generator, slowing the locomotive speed without causing wear of the wheels. When the brakes are applied, the pneumatic switching stops the engine and stops the fuel pump, turning off the indication lights. Chapter 2, Maintenance and Repair.